Hi to all my Brainerians. In this video, I will explain certain numericals based on the quantization of charge and Coulomb's law. These topics I have explained earlier in my previous videos. For more reference, you may watch these videos. Now I will explain some key points in solving the numericals and some common mistakes that students do in exams. So let's start with the questions that have been previously asked in CBSE boards. Now we will start with the first formula, that is quantization of charge, which is Q equals to NE. About this formula I have already explained in detail, and in this video we will be discussing about how to use this formula in a numericals. Second, we will be using the concept based on the Coulomb's law, that is Coulomb's law formula we will be using. What are the formulas we have learned in the previous topics? That is the formula of force between the 2-point charges present in vacuum, formula between the 2-point charges present in a certain medium, and the relative permittivity, that is epsilon r, which is equals to the ratio of the two permittivities, that is the permittivity in the intervening medium to the ratio of absolute permittivity in the free space. So now let's start with some of the questions that have been asked previously in the CBSE boards. The first question is, let us go for the first question. The question says, which is bigger, a Coulomb or a charge on an electron? And how many electronic charges form 1 Coulomb of a total charge? So the answer for this question will be the obvious, that 1 Coulomb of charge is bigger than the charge on an electron. Let us see how is it. The charge on an electron, all of us know that the charge on an electron is E, that is equals to 1.6 into 10 to the power minus 19 Coulomb. That is, it is having a charge of 10 to the power minus 19 Coulomb. Now let's calculate the number of charges present in 1 Coulomb of charge. So for that we have to use the formula N equals to QE, which is the based on the quantization of charges, that is N equals to Q by E. Here we have to put the magnitude. For Q we will be putting 1 Coulomb. For E we have to put its magnitude, that is the numerical value 1.6 into 10 to the power minus 19. On solving this, we are going to get 6.25 into 10 to the power 18 electrons. So in 1 Coulomb this many number of electrons are present, that is, and there we are having the one charge on an electron is this much of the Coulomb. So naturally what we can say is that the number of electrons that are present in 1 Coulomb of charge is 6.25 into 10 to the power 18 coulombs. So obviously 1 Coulomb of charge is bigger than the charge on an electron. Next question, calculate the charge carried by 12.5 into 10 to the power 18 electrons. Mind it, here what are the parameters that have been given? We have to first concentrate on that. So first of all, here the number of electrons have already been given, that are 12.5 into 10 to the power 8, and we have been asked to calculate the charge carried by this much number of electrons. So which formula naturally we have to use? We have to use the quantization of charges, that is Q equals to N into E. Now the value of E is standard, which is 1.6 into 10 to the minus 19 Coulomb. So in this formula, if you will put the value of N, which is 12.5 into 10 to the power 8, which is given, the standard value of E, which is by default, it is always 1.6 into 10 to the power minus 19 Coulomb. On solving this, we are going to get the result Q equals to 2 into 10 to the power minus 10 Coulomb. That means the charge carried by this much number of electrons will be 2 into 10 to the power minus 10 Coulomb. This is how you will have to present your answer in the given format, so that there will not be any chance of losing the marks. So let's have then look at the next question. What is the next question? It says that the two identical charges capital Q each are placed at a distance of r from each other. A third charge small q is placed on the line joining the above two charges such that all the three charges are in equilibrium. This is our key point over here. Three charges have to be in equilibrium. So what will be the magnitude, sign and position of the charge small q? So first of all, we will depict the given situation in the form of a figure. We have to place the two identical charges capital Q and capital Q at the points A and C respectively, separated by a distance of r. Now where the third charge small q must be placed, the small q must be placed in between the line joining the two charges. Then only the system of all the three charges will be in equilibrium. If you place them either to the right side or to the left side, all the three charges will never be in equilibrium. So in order to satisfy the given condition, if q is placed at a distance of x from A and B, then what condition we will be having? The charge will be, the small q will be in equilibrium if the forces exerted on it by the charges at A and C must be equal and opposite. Now when q is placed at a point B, now the charge which is at A and the charge which is at C, they will exert equal and opposite force on the charge small q. Then only the small q charge will be under the equilibrium condition. On putting the magnitude part in the formula, what we will get, this is the force between the charges at the point A and B, and this is the force which is present between the charges at point B and C. This is B and C. They are separated at a distance of r minus of x. Why? Because the total distances are, out of which the distance between A and B is x. So what will be the remaining distance? The remaining distance B and C will become r minus of x. So this is the two forces that are present on a small q charge because of the charge at A, and this is because of the charge at C. On cancelling the like terms, what we will get on this term, and on solving the term, we will get the position of a small q must be at r by 2. That is, a small q must be placed at the center of the line joining the two charges. Now the key point must be in order to find the sign of a small q. Now how we can find the sign of a small q? The sign of a small q we can get by considering a concept that if capital Q is to be in equilibrium condition, if capital Q is in equilibrium condition, that means the two forces which are present on capital Q must cancel each other. Now what is the force which is acting on the charge which is present at A? The C charge will be repelling this charge in this direction. The charge at C will be repelling the charge at A in this direction. So the charge at B, which is a small q, must attract the charge at A, so that the charge at at A will become in equilibrium condition. So the charge at A is under the two forces. One is the attractive force by the small q, and one is the repulsive force exerted by capital Q. This is the key point. This is the key point or the deciding factor which will decide what should be the sign of small q. So the sign of small q has to be opposite to that of the capital Q. Then only the system of all the three charges will be in equilibrium. If you will take the sign of small q as same to that of capital Q, then the three charges will never be in equilibrium. Keep this key point in mind, that if the system of three charges are in equilibrium, the third charge has to be in opposite in nature. So now after that, our given condition will be force of repulsion between A and C must be equal to the force of attraction between A and B. So the repulsive force between A and C, that is repulsive force between capital Q, and the force of attraction by the small q must be same. That is, on putting the magnitude form, we can get this cancels out. So what we are left with, Q equals to Q by 4. So this is the magnitude part. What is the sign of the small q? Sign of this is just opposite. Here, mind it, here we are not mentioning the sign of Q is positive or the sign of Q is negative. We are not mentioning any of the sign. We are just mentioning whatever be the supposed sign of the capital Q, the opposite sign must be carried by the small q. That should be your answer, not in a way that it should be positive or negative. This is the key point where you have to give the stress. The sign must be opposite to that of capital Q. Now next question, let's say another question which is again based on the condition of equilibrium. Now 2 point charges of charge values capital Q and small q are placed at a distances of x and x by 2 respectively from a third charge of value 4q. All charges being in the same straight line. Now calculate the magnitude nature of capital Q charge such that the net force experienced by the charge Q is 0. Here we have to take the two conditions. One is of capital Q charge and the other one is of the small q charge. Keep this in mind. In the previous question, we were having the equilibrium condition when all the three charges were in equilibrium. Here only a small q charge is in equilibrium. So let us see first of all how the three charges can be placed. The three charges we are placing according to the figure. Here, from a charge 4q which is placed at A, the capital charge q which is placed at B is at a distance of x, and the another charge small q which is placed at a distance of C at a distance of x by 2 from 4q. Now what will be the key point over here in solving the question? For the equilibrium of the charge small q. Now according to our question, small q charge is at equilibrium. Under which condition it will be equilibrium? When it is under the experience of two equal and opposite forces. Now C will experience a force from A and C will experience a force from B, and these two forces must be equal and opposite, that is FA and FB must be equal and opposite. So what we can depict is that the charge on capital Q must be same as that on the charge of 4q. Then only the C will be under the action of two equal and opposite forces. So what will be the sign of capital Q? The sign of capital Q must be the same. Here again we are not mentioning that the sign should be the positive or sign should be the negative. Here we are just mentioning the sign of capital Q which is at B must be similar to the sign of 4q which is placed at A. So this one will be your key point. It is not opposite. Otherwise, the charge at C will not be in equilibrium. Now again, so according to our this key point condition, FA must be equals to FB. Now we have to put the Coulomb's law. What is that? X by 2 and X by 2. We have to put the formulas over here. So both of them are at a distances of X by 2 and X by 2. So like terms get cancelled out, and we will get the magnitude of capital Q as equals to 4Q. So here again the concept we dealt with is the condition of finding the based on the equilibrium forces, based on which we have found the sign of the charge and the magnitude of the charge. Now any question which is based on such concept will be asked, you must be able to give the answer. Try to go for some more questions. In the coming slide I will give you some questions. Please try to solve it. Let's go for solving some questions previously asked in CBSE based on these topics. So here are these questions. In case you find any difficulty in solving these problems, please do mail me at this ID. I will provide you with all the solutions.